Good morning, everyone. Let's start my presentation. I'm going to talk about consistent nonlinear Winkler-based beam element for nonlinear underground structures. Prior to main presentation, let me introduce myself briefly. My name is Jung-Soo Kim. I am a PhD student in Applied Mechanics Laboratory. I am lucky to have been advised by Professor Moon Kim, and after entering this graduate school, I have some project experiences on underground structure, such as tunnel and pipelines. With my project experiences, I have studied on the numerical analysis of tunnel related to compass behavior and soil structure interaction. I recently published a SIE paper about applying linear Winkler-based beam element to tunnel analysis. So, in my dissertation, this contents is included as one of the main subjects, and the proposed element is also extended to fully nonlinear analysis. Let's begin main presentation. Now, Winkler-based beam element will be called as WBB. WBB is one of the most used elements for footing and pile analysis. This element is simple, but can reproduce various soil structure interaction with low computation cost. WBB model has some benefits with respect to numerical analysis. To emphasize on WBB, comparison between the WBB and BS model is shown in this slide. The first, WBB is a special beam element considering the ground stiffness and ground direction. So WBB does not need to create spring elements. Second advantage is fast convergence. This figure shows comparison between WBB and BS models for footing about convergence. And you can see the fast convergence rate appeared in this graph. Finally, in beam spring model, BS model, mature input parameter is dependent on element size. The table shows formulas for normal spring coefficient of BS model. Note that these equations included terms related to structure geometry, such as footing width, tunnel radius, but WBB is not. Because the fact that elastic modulus of material is independent of element size in finite element analysis. Although there exists some benefits, the use of WBB is limited to flat geotechnical structures. Study on advanced WBB is also limited to that. This limitation is due to determining the ground state in WBB. It will be explained in detail later. However, considering the advantages of WBB model, it can be worthwhile to expand its application. For this reason, this study has following objectives. First, process will be proposed to constantly determine the ground state in WBB. Second, WBB will be extended to fully nonlinear analysis for considering nonlinearity of ground and structure. This diagram shows overall composition of my presentation. Present WBB will be explained by dividing two parts, the structure and ground. All those numerical examples were conducted, but there will be skipped to focus on explaining the reason difficulty related to the determining ground state. For such reason, comparison analysis will be skipped. WBB can be derived from beam on Winkler foundation. The Winkler foundation includes Winkler foundation includes the assumptions that ground reaction is proportional to its lateral displacement. In this study, WBB formulated incrementally to conduct nonlinear and hysteretic behavior of structure of soil structure interaction. As you can see, the element equation of WBB appear in compact matrix equation. Full description of this equation is very long, so specific description is also skipped. And note that this element include terms related to ground stiffness and internal force. To consider nonlinearity of the structure, the layered section method is adopted. In layered section method, the cross section of the beam is divided into a bundle of layers. Then the uniaxial material models is assigned to each layers. This enables WBB to simulate various nonlinear composite behavior. The history groups of material model used in this study are shown in this slide. The first one is Kent-Scott-Park model. This model is often used for concrete material. The other one is isotropic linear hardening model. On the other hand, to be realistic soil structure interaction analysis, it is important to consider that ground has weak resistance to tensile load. The developed WBB can simulate tensionless and hardening behavior of ground using these two models.